Okay, so we're going to start a new unit on solving quadratics by factoring. And I'm going to kind of warn you that we're going to go kind of quickly because we're facing that SOL deadline. So what are you going to learn today? Today we're going to learn how to solve a quadratic by factoring and what the zero product property is. And that's actually what we're going to use to solve by factoring. So the zero product property basically says for all of your real numbers, A and B, if A times B equals 0, then A equals 0 or B equals 0. So what that implies is that if I have these two factors, x plus 3 times x plus 2, so that makes them factors, equals zeros, one of them has to equal 0, or both of them have to equal 0. And we're going to take the case that both of them are going to equal 0. So that's going to let us solve a quadratic by factoring. Now remember, I told you when we did this factoring unit, you had to know how to factor. We're going to keep on using it. So to solve a quadratic by factoring, and remember, quadratics are equations that are in the form ax plus bx, ax squared plus bx plus c equals 0. Okay, so we're going to get everything on one side, or set equal to 0. We're going to factor. We're going to set those factors equal to 0, and then we're going to solve all of the equations that result. So here's our first example. Now notice everything is already equal to 0, and it's already factored. What I mean by already factored is I've got two binomials, or I've got things multiplied together to equal 0. So all I have to do is set those factors equal to 0. So 3y minus 5 equals 0, and y minus 2 equals 0. I don't know why my computer's been doing that. All right. So if I go to solve this, I'm going to add 5. Yes, I want to see this work. I'm going to get 3y equals 5. If I divide by 3, y equals 5/3. Then I'm going to add 2 to both sides, and I'm going to get y equal to 2. So I have two solutions. I've got y equal to 5/3. I've got y equal to 2. If I want to write it as a solution set, I'm going to use brackets or braces, 5/3 and 2. It doesn't matter. I would accept either solution, or you can just box your answers. Okay? This is an and or an or situation. Both things can't be true. So y is going to equal either of those things. So here's another example, already factored. I've got three factors this time. I've got x plus 3, and I've got 2x minus 5. And I set them equal to 0. So x equals 0, x plus 3 equals 0, and 2x minus 5 equals 0. So this one's already solved, so x is 0. If I subtract 3 from both sides, x equals -3. If I add 5 to both sides, 2x equals 5. And if I divide by 2, x equals 5/2. So my solutions, I've got 3 of them. I've got x equal to 0, -3, and 5/2. Okay, all 3 of those are going to work. All right, now in this example, notice that we don't have the set equal to 0. So I need to bring the 21 over to the other side, and I'm just going to bring it over and make it its opposite. Okay, so I'm going to get 3x squared minus 2x minus 21 equals 0. Okay, and so now to factor it, I need factors of 6 times -21 is -63. That add up to -2. And hopefully you're getting better at this factoring. So my factors are going to be -9. Well, I don't know why it does that. -9 and 7. When I multiply them, they equal -63. When I add them, they equal -2. So remember, we're going to split the middle term so that we get 3x squared minus 9x minus 7x minus 21 equals 0. I'm going to use my factor by grouping, so I'm going to factor out a 3x here. So I get 3x times x minus 9 out of here, or I'm sorry, x minus 3. I'm going to factor out a negative 7, and I'm going to get x minus 3. All right, so Miss Craig has messed that up. This should be x plus 7. We're going to factor out a positive 7, and then we would get x minus 3 equals 0. Now, I want you guys to notice. Do you notice how when I got to this point, I said, hey, I made a mistake? That's because I know my binomials have to be x minus 3, okay? And they weren't. So I looked up here to see what my easy fix was and where my mistake was. And it was that I had written it as minus 7x instead of plus 9x. Okay. So now my factors are going to be 3x plus 7 and x minus 3, and that's equal to 0. So now we take our two factors, the 3x plus 7 equal to 0, the x minus 3 equal to 0, and I solve those. If I subtract 7 from both sides, I get 3x equals negative 7. If I divide by 3, I'm going to get x equals negative 7/3, and we're just going to leave it as a fraction. Okay. If I add 3 to both sides on the second factor, I'm going to get x equal to 3. So in this case, x is equal to 3, and x is equal to negative 7/3. Okay. With braces, it's just a solution set. So another example. Here, I'm going to bring my 121 over to this side by making it its opposite. So I get 36w squared minus 121 equals 0. Now, these are both perfect squares, so that's going to factor to 6w minus 11 and 6w plus 11 equals 0. If I set each factor equal to 0, I'm going to add 11, so I get 6w equals 11. If I divide by 6, w equals 11/6. If I subtract 11, I get 6w equals negative 11. If I divide by 6, w equals negative 11/6. Now, when I write this as a solution set, I'm going to get negative 11/6 and 11/6. You could also write this as w equals plus or minus. So this means positive or negative 11/6. And either is acceptable way to write it. Okay. Another example. Here it looks like I've got a common factor of 5k, so I'm going to factor out my common factor. You guys forget to look for this all the time. Look for it, okay? So I'm going to divide everything by 5k, and I'm going to get k minus 25 equals 0. This is factored, okay? So I'm going to set each of my factors equal to 0 and solve those resulting equations. So if I divide by 5, k equals 0. Remember, it's a solution. It has feelings. We just don't say there's no solution because it's 0. 0 is a valid solution. If I add 25 to the second one, I'm going to get k equals 25. So my solutions are 0 and 25. Okay. Last example. Now here's the deal. This one's factored, but notice that it's not set equal to 0. So what we have to do is we have to distribute our n. So we get n squared plus 2n. And I'm going to bring this to the other side and make it its opposite. So minus 15 equals 0. And then I need factors of negative 15 that add to positive 2. So that is going to be n plus 5 and n minus 3 equal to 0. Remember, 5 times negative 3 is negative 15. If I add 5 and negative 3, I get positive 2. So setting each of those equal to 0. And solving, I'm going to subtract 5. And I'm going to get n equals negative 5. I'm going to add 3. And I'm going to get n equal to 3. And there are my solutions. Okay. So I'm going to recap. To solve quadratics by factoring, we're going to get everything on one side or set equal to 0. We're going to factor and set factors equal to 0. Then I'm going to solve all of these equations. Okay. Now I've gone over this in class as well, so you didn't have to watch a video over your 3-day weekend. So this is here for reference. Have a great night, and I will see you in class.